So let's get started. Oh, come on. Before starting, I said I'll upload this video on YouTube, so it's obvious that I'm going to speak in English. Actually, I have two versions of English accent. One is British and one is American. So if I calm down, then my British accent will come out. And if I'm a bit nervous, then my American accent will
야,
come
우리
out.
박수 한번 쳐주자. 응?
So that is one notice to let you know. So now we are group 5 and our building title is Cuckoo Building because its levels are 99 levels. So next. So our contents are following. So first of all, design overview. First of all, our design motivation and purpose. Next, design overview. Third, structure optimization process followed by final model overview. Finally, analysis and quantity calculation and comparative analysis. Now let's go to chapter 1, which is motivation and purpose. Our professor taught us many things to use, such as iron frame, tuned mass damper, and so on. But we found out that JD Tower, which will be completed in 2020, and many other skyscrapers are built by concrete. So, because of it, we decided to build our model based on concrete. Next. Chapter 2, design overview. This is our building located in the middle of California. The ground condition is being rock based on code IBC. Seismic resistance system is E8. Ordinary reinforced concrete shielders. R factor is 5.5, CD is 4.5. Its height is 435.6 meters, and its slenderness ratio is 8.7. Its stories, levels and heights are 99 floors and 4.4 meters, and we use, as I said before, reinforced concrete. Next, please. So, wind load and seismic load is gain obtained by putting these values in this program. And of course, live load is 6.0 kilonewton per meter square, and fixed load is 4.0 kilonewton per square. Next. And now let's talk about the base building. This picture is a picture from above, and it's, as I said before, its height is 435.6 meters, and its size is 50 by 50, and slenderness ratio is 8.7, and the strength of component is C40. Next, please. And see this pink thing? Pink thing is actually beam. Its size is 0.3 meters by 0. Oh, there's this correction. Actually, that should be 0.2 meters. And the green thing is cobalt, and its thickness is 600 millimeters. Next, please. And these two colors are walls, columns, and these blue sky columns is just small columns. There's no big difference, but just size is different. So the blue columns size is 1 by 1, and it has 32. And yellow columns are 1.5 meters by 1.5 meters, and we have 12 columns. Next, please. And based on that, we just build buildings, and that's so. By building through this had, of course, two problems. We gained displacement of roughly 6 meters, and in other words, 1 over up to 10 seconds, so we need to reduce the period. Next, please. So, we have to gain an idea. So, here's one idea. Idea 1, concrete outrigger belt wall system. So we found out that Elsa Kika Shop located in Haeundae, used outrigger belt wall system. Unlike outrigger, next please. Unlike outrigger belt truss system, outrigger belt wall system doesn't use any iron frame. So instead, they use shovel. Before moving on, let's take a brief look at the difference between belt truss and belt wall. So talking about the economics, belt truss is better than belt wall, but in the aspect of lateral force resistance, belt wall is better than belt truss. Next, please. So by adopting outrigger and belt wall in 33 floor, 66 floor, and 99 floor, we got the displacement and period decreased. Next, please. So those are results, but still it's 1 over 200, so we need to decrease the displacement, and next, please. And also the period was 14.24 seconds, so that doesn't meet our goals, so we need to decrease the period also. And so back to the base building, we need another ID. Next, please. So what we found out is John Hancock Tower, located in Chicago, that used the braced frame. So it is instead of making hole inside, putting X-shaped brace frame on archboard. This may not only reducing the budget, but also enabled a building to endure more wind load. So next, please. So we adopted every 11th floor. We adopted the X-shaped brace wall. So we try to decrease the period and displacement. Next, please. So by adopting the X-shaped braced wall, we got the displacement 1 over 476. But then it also decreased because our aim is 1 over 500 or 1 over 800. And next, please. And also, period was 10 seconds, roughly. And that's really close to our aims, which is 8 to 10 seconds. So we've got to work on how to decrease the displacement. So we just think about 4 days, and finally, what if came up? What if we mixed both things? So it means we add outrigger and belt wall system plus X-shaped brace wall. So next, please. So by using outrigger and belt wall system, we didn't use iron frame, and also X-shaped brace wall system is kind of bracing that can reduce period and displacement. So next, please. So those are results. So this is a combination of outrigger and belt wall plus X-shaped brace wall. So we got, next please. So we got the displacement 1 over 556, which met our goal. And next please. And period of 9.5660 seconds, which also met our goal. So next please. So it's about optimization. So next please. But so we ran to the lab and ran minus, but the thing is, design was not good. And next please. Also, actual load ratio was not good. Next please. So the reason why we got actual load ratio and another NG, it was because it's so heavy that the iron cannot withstand the building. Next, please. So we increased the strength of concrete and we increased the component. So the white color lattice are before changing, and the yellow colors are after changing. So next please. So after doing like that, but also we failed to manage the design was engine, and next please. So we put another. So we did the same things. So we strengthened the concrete, and we also increased the component. So again, the white colors are before changing, and the yellow colors are after changing. So if you see the difference between before and after, we just unificate the 34 to 66 levels and 67 to 99 levels. So that's kind of a big difference between before and after. So next please. So beam design was great, and next please. And wall design was great, and next please. And also column design was great, so everything seemed really good. So next please. But the thing was that displacement and period was way too short to our goals. So next please. Yeah, so the improvements, this is, so we have to increase the displacement and period until it reaches our goal. So we succeeded in designing, but in this case, its period and displacement was way too small. So next please. So we changed, so we decreased the concrete strength and we decreased the component. So the white lattice are before changing, and also the yellow lattice are after changing. So next please. And still, we didn't manage to make the displacement into our goals, but period has reached our goals, so it's kind of half succeeded. So next please. So we just leave out some of the wall brace and outrigger and butt plate. So actually 67 to 99 levels we had wall brace, outrigger and belt plate. But in this picture,
Wall brace spinning is wrong.
yeah, sorry about that. I may ask you for your excuse. And left out. So that's not a big change in some aspects, but in other aspects there's a big change. So next please. So this is also another picture showing before leaving out the components and after leaving out components. And next please. So still, it's the same results. Displacement didn't reach our goals, but period has reached our goals. So next please. So we have to left out the beam and column. So before it was just a square type building, and now it shows that these two, after 67 level to 99 level, the size of the scale is reduced. So next please. So the left side is before leaving out the components, and right picture is after leaving out the components. So next please. So it's another aspect, another picture from leaving out. So next please. And yet again, we have the same results. Displacement didn't meet our goals, but period met our goals. So next please. So we decided to again leaving out the beams and columns. So next please. So there's a big difference between 67 to 99 levels, because at previous 64 levels up to 99 levels were the same shape but now it's a different shape than before. So next please. And then we succeeded. Actually, displacement reached our goals, and period also reached our goals. But it's kind of making us read that thinking about economics, if we leave out more components, then we could get more good grades. So we tried again. So next please. Oh, okay, but beam design was good. Next please. Wall design was also good. And column design was super good. So next please. So we left more components as I said before. So next please. So we unificate the 34 levels to 66 levels with the shape of 67 levels to 99 levels. And the 34 levels and 66 levels came down to 1 to 33 levels. So the shapes are like this, and next please. And displacement met our goals, and period was similar to our goals, and next please. But in the design, it was not good. Next please. So, because in case 3-5 had NG in design, so we finally chose case 3-4. So let's take a look at case 3-4. Next please. Next please. Okay, so this is a picture from 1 to 33 levels. And next please. And this is another picture from 34 to 66 levels. Next please. And this is 67 to 99 levels. So next please. And in the middle, in 33 floors, we put cold walls. Next please. And outrigger walls. Next please. And belt walls. Next please. And in the 66th floor, we put outrigger walls. Next please. And X-shaped brace wall was added 1 to 66 floors. Next please. So this is a table, material used in the building. And next please. And this is the result of displacement and period. So displacement was 1/712, and period was 8.406. Next please. And this is drawing brief, and we obtained all okay, so that's also good. And next please. So it's quantity analysis. So it's about concrete. So in this case, we can see that concrete sum is 0.36, and using the beams, we got 0.54. So final summation is 0.9. Next, please. And quantity calculation about steel, we got 0.0756. Next, please. So this is a table and a graph. So table is about summation of how many we used of concrete and steel. And the right side graph shows the green dot is our model, and the orange dots are the famous skyscrapers in the world. So, and the graph x-axis is slenderness ratio, and y-axis is concrete quantity. So we can see that our model is also good. Next, please. And it's model mass participation. So in our case, if you see the outstanding numbers like TX1, TX2, or TX3, that there is a modification occurs at that time. But we can see that TX2 and TXY has the same mode number and outstanding numbers. And I'll explain that later. So if sum is over 95%, it's okay. So after 25 mode, we got all the 95. The summation was all 95. Next, please. Oh, back to. So before leaving this table, I have to speak the same modification. So our building is square shaped. So we got the same outstanding numbers, not the same, but same action occurs in the same time. So next, please. So this is Y shaped through the X. And next, please. And this is Y shaped through Y. Next, please. And this is Y shaped through Z. Next, please. So now is a variation of damping and the displacement. So the period was all the same, 8.4 seconds. And eventually, if damping increases, displacement decreases. We can see that. And next, please. So we can see that question mark. And this slide shows on how we get damping ratio. So the left side picture is the elements that damping ratio doesn't affect, and underneath is the elements that damping ratio affects. So after this slide, like we had calculation for about 6% of damping ratio, and it always get the same. So next, please. So in the damping ratio 1%, we've got the scale-up factor 1. Actually, Cm is equals 0.711, which is less than 1. Then we just make the scale-up factor as 1. So next, please. And this is damping ratio 2%, and this is what we settled down. And the Cm equals 0.707, which is less than 1. And again, it becomes the scale-up factor equals 1. Next, please. So let's just do all the same calculation that we did. Next, please. Next. Next. Okay. So is a graph that even though damping ratio increases, the Cm decreases. So Cm was always less than 1, so we just can see that. We can assume that scale factor is 1. So next, this is response spectrum analysis. So in minus y-axis means different from what we have to do. So through this process, we got the correct y-axis. So next, please. Just this shows on how we got the correct y-axis through Excel. So next, please. And next, please. And next, please. So actually, our team is put great effort on making this graph. So through Excel, they put all the data they got from minus and made this graph. So this is it. Next, please. So just because the thing was all the same in front of this, so we just expanded this. So we got another kind of this graph. So I think this is end of what we're going to throw about the minus and other models. So next, please. So let's talk about models. So the purpose of models is creating creative through the team project, and we built a small version of the model. Actually, it's really shameful to say that our actual model is a bit failure, because in actual minus, we kind of, our building was narrow shaped as we go up, but in this case, we lack of money, lack of budget, so we only just express 1 to 33 floors. But the brace, X-shaped brace, we've got to express that. So inevitably, we put some black stickers outside the walls, so you can know that it's an X-shaped brace wall. And this is a small version of our 33 floors. So it's kind of, it has used outrigger and belt wall system, and this is our model. And next please. And okay, so the materials that we used by building these models are mainly acrylic, and just in the bulkwork we use silver drop. So the scale is 350.1. So this is the process of how we made the models. And next please. So as I said before, the black sticker is outrigger and belt wall system. So you can see through the models. And next please. And to show the detail of outrigger and belt wall, we made another 33 floor models. So you can see more detailedly. And next please. And it's what we thought through making models. So, and this is, I think you can just read it because it's just our thoughts. So I think this is end of our presentation. Thank you for listening.